Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin. There is a silence that wraps the universe, softer than sleep and deeper than the sea. It lives in the spaces where light has yet to arrive, where even time seems to hesitate. This is the quiet that lives between the stars, not the quiet of a still room or the hush of snowfall, but something older, colder, and more complete. It is the quiet of near-perfect nothingness, a place so empty, even temperature itself struggles to exist. And yet, in that quiet, something beautiful begins. Far from any sun, in the vast reaches between galaxies, there are places so cold that atoms barely move. It is not darkness alone that defines them, but stillness, an exquisite kind of stillness that only the universe could create. At these temperatures, molecules slow down to a near stop. Vibrations fade, heat retreats, and even the hum of radiation becomes a whisper. Scientists call it the cosmic microwave background, a faint echo from the birth of everything. It glows not with fire but with memory, spread across space like a soft, invisible mist. Now imagine drifting there in the vast, dark ocean between galaxies. You wouldn't feel wind or gravity or warmth. The stars would be scattered pinpricks of light, each one impossibly far away, each one alone in a sea of silence. And yet the cold wouldn't feel empty. It would feel like something sacred, because in that stillness you'd realize, this is not the absence of life. This is the space that makes life possible. The cold of space is not harsh. It is careful. It slows things down. It preserves. Without cold, ice would never hold the memory of planets. Comets would never carry water across the solar system. Proteins would never fold just right. Even your own body, full of warmth and breath, depends on cold in hidden ways. Deep in your cells, enzymes pause in perfect balance, waiting for the right signal. Your brain cools slightly while you sleep, like a machine resting to repair. The cold does not destroy, it listens, it steadies. At the edge of known temperature is something called absolute zero. It is not just cold, it is the idea of no heat at all. 0 Kelvin, a point where motion itself stops. Nothing in the universe can quite reach it, but we can get close. In special laboratories on Earth, scientists use lasers and magnetic traps to slow atoms until they barely tremble. They create clouds of matter so cold they begin to behave like waves. This is called a Bose-Einstein condensate, matter melted into stillness. It is not just a scientific trick, it is a glimpse of what the universe becomes when all energy rests. These places, between the stars, inside laboratories, hidden in frozen caves beneath the earth, reveal something true about cold. It is not absence, but invitation. The colder things get, the more we notice what remains, the more we listen. The faster we live, the more we miss the quiet. But in the cold, everything slows. Time opens its hands. Patterns emerge. We can finally see what heat always hides. If you have ever touched snow and felt it sting, or walked outside on a winter morning and heard the sound of frost underfoot, you've touched the edge of this cosmic silence. You've felt a hint of that beautiful stillness the universe keeps in its deepest pockets, and maybe for just a second, you understood. Cold is not the enemy of warmth. It is the canvas that lets warmth shine. Even in the coldest corners of deep space, warmth is still trying. Stars still burn in the distance. Planets still whisper their orbits. Dust still dances, slowly, almost invisibly. There's motion but no rush. Light but no glare. It is the softest kind of persistence, a reminder that even the quietest parts of the cosmos are alive in their own way. And that's the strange beauty of it. Cold gives us contrast. Without it, there would be no stars to pierce the night, no dawn to melt the frost. Without cold, we would not know the miracle of fire, or the comfort of a hand held close, or the power of breath in winter air. Cold does not take away. It teaches. It shows us what matters. So when we say the universe is cold, we are not mourning, we are marveling. We are standing in awe of a place so vast, so quiet, so carefully tuned, that it can cradle both fire and ice in the same sky. we are listening to a silence that holds galaxies apart, but also holds them together. We are remembering that beauty is not always bright or loud. Sometimes it is the hush between stars, sometimes it is the coldest place in the universe, and sometimes it is the wonder we feel when we stop to notice how gently the cosmos breathes. Let's drift deeper now, into the places where even light seems to hesitate. In the great void between galaxies, where temperatures fall just above absolute zero, the fabric of space becomes a kind of cradle. Here, cold is not a condition, it is a language. A gentle hush that speaks not in heat or motion, but in stillness and time. The universe at its coldest moves not in chaos, but in careful rhythm. It slows everything just enough for structure to take hold, for patterns to form, for beauty to reveal itself not in fire, but in the soft persistence of frozen balance. In this slow-motion world, the tiniest particles become storytellers. Hydrogen atoms, drifting endlessly through interstellar space, carry the memory of the universe's beginning. They are the oldest wanderers, untouched by stars or planets, moving through the silence like ancient seeds. It is in these coldest spaces that molecules can cling together without being torn apart by heat. Over time, dust and gas, barely warm enough to move, gather patiently. And from that gathering, stars are born, not in firestorms, but in clouds colder than Arctic nights. These clouds are called molecular clouds, and some of them are so vast they stretch for hundreds of light years. Within them, temperatures hover just above absolute zero, colder than anything found on Earth's surface. And yet, within their icy shadows, warmth begins. Gravity tugs, dust spins, atoms collapse inward. A spark forms, and slowly a star wakes up. But before that awakening, there is waiting. There is cold, there is silence. And that silence is not empty. It is the breath before the song, the stillness before the bloom. Back on Earth, we might think of cold as lifeless, a frozen pond, a winter storm, a breath that turns to fog. But in the universe, cold is where life begins its long, patient journey. Comets, the icy travellers of our solar system, are time capsules of that journey. Born in the frozen outskirts far beyond Pluto, they carry water, carbon, and simple molecules, some of the same ingredients that seeded life here. When one of these cold wanderers falls toward the sun, it begins to melt, and it releases not just vapour but memory. A whisper from a colder, older time. Even our own planet holds cold in its bones. Beneath glaciers, ancient air bubbles tell stories of climates past. In the deep sea, where no sunlight reaches, entire ecosystems thrive in near-freezing blackness, warmed only by the faint heat of the Earth's core. And above it all, circling silently, our atmosphere protects us from the deadly chill of space. But beyond that thin shield, everything changes. The universe returns to its default state. Calm, dark, cold. Some of the coldest objects in the universe are white dwarfs, the quiet remnants of once bright stars. After burning through their fuel, they collapse into dense, Earth-sized cores. At first, they glow fiercely, but over billions of years they cool, they fade, and eventually they become what scientists call black dwarfs, hypothetical stars so cold they emit no light at all. None have been found yet. The universe is still too young for one to exist, but one day, far in the future, the sky may be filled with them, cold stars sleeping forever. And what of the cold that we can make? In laboratories, physicists have built machines that cool atoms to billionths of a degree above absolute zero. At those temperatures, strange things happen. Atoms lose their individuality and begin to act like one. They blur, they stretch, they enter a state of matter that exists nowhere else in nature. A Bose-Einstein condensate. This is not just a scientific achievement. It is a mirror held up to the universe, a reminder that cold can unlock secrets heat never could. In the realm of quantum physics, temperature is more than comfort. It is control. Cold lets scientists slow time, slow movement, and observe the tiniest dances of particles. Cold reveals the outlines of invisible worlds. Lasers, superconductors, quantum computers all rely on chilled precision. And yet they are also works of patience. It takes time to cool something properly, time to still the chaos, time to listen. There is something almost spiritual in this, that in order to understand the deepest truths of matter, we must first quiet it. That discovery doesn't always come from smashing or burning or accelerating, but from slowing, softening, cooling. This is a kind of science that feels less like conquest and more like care, less like heat and more like breath. In ancient times, people looked up at the stars and saw fire. Today we know that beyond that fire is cold, vast, magnificent cold. And it's not a threat. It's not a warning, it's a stage, a space where time stretches long enough for galaxies to form and life to emerge. The cold doesn't fight life, it frames it. Without the silence, the song would be noise. Without the dark, the stars would disappear. Without cold, the universe would never have paused long enough to dream. So next time you step outside on a winter night and the chill touches your skin like a whisper, remember that this feeling connects you to something vast. The same cold that formed your breath also shaped the stars. The same silence between your thoughts is mirrored in the silence between galaxies. And the beauty of it all is not in the extremes, not in fire or ice, but in the way they meet, in the way they balance. This is the gift of the coldest places, not just their mystery, but their clarity. They show us what happens when the world slows down, when noise fades, when movement pauses. They show us that stillness is not the absence of life, but the stage upon which life performs its most delicate work. And in that realization, in that quiet, we find not just science, but something that feels like wonder, something that feels like home. Imagine for a moment that you are floating, not falling, not flying, but drifting, in a stillness so complete it feels like sleep. Around you there is no sound, no rush of wind, no heat from any sun, only darkness, endless and soft, with stars glittering like forgotten wishes. This is not loneliness. This is not emptiness. This is the quiet that holds the universe together, the quiet that lives between the stars. And as you hover there, wrapped in that deep hush, you begin to feel it, not just around you, but within you. The cold becomes a presence, gentle and vast. It is not something to escape, it is something to understand. In this kind of silence, you begin to hear things differently. You notice how the universe hums in frequencies far below sound. You begin to sense that time itself flows more slowly here, stretching like taffy pulled by invisible hands. Cold changes the tempo of everything. It lets moments breathe. It makes space for reflection, for stillness, for memory. And it is in this space that some of the most fragile, most miraculous events in the cosmos unfold. Think of the interstellar clouds where stars are born. These clouds do not roar, they do not burst. They simply wait, suspended in cold, their particles drifting closer over millions of years. A balance so delicate that a whisper of pressure, a passing wave of gravity, can tip it into something new. From that quiet, from that patience comes light. Not because the cold failed, but because it made room. Cold is not the opposite of life. Cold is the pause that lets life begin. Now let's return to Earth, where cold plays a quieter role, but no less vital. In the polar ice sheets, miles deep, tiny bubbles of air have been trapped for hundreds of thousands of years. These bubbles are voices from the past. They carry the breath of ancient forests, the sigh of long-dead animals, the trace of forgotten winds. Scientists read them like pages of a book, learning how our planet has danced with temperature over time. The cold, again, is a keeper of memory. In your own body, cold slows your cells, slows your breath, slows your mind. In certain medical procedures, cooling is used to preserve tissue, to delay damage, to buy time. Cold shelters what matters. It does not erase. It protects. It whispers, wait, rest, not yet. And in those moments, life listens. Even language changes in the cold. Words become quieter, voices lower. Movements soften. People gather close not just for warmth but for connection. Cold teaches us intimacy. It draws us near. It reminds us that warmth is not just temperature. It is presence, touch, togetherness. And just as the stars burn more brightly against the black of space, our human moments of warmth shine more clearly against the cold. When we study the coldest places in the universe, we are not studying lifelessness. We are studying what remains when everything else falls away. What persists, what endures. The cold shows us what the universe is made of when it is not flaring, bursting, or burning. It shows us the quiet foundation beneath the noise, and it shows us that beauty doesn't always need to glow. Sometimes it just needs to be still. Look again at the night sky. Most of what you see is not light, but the space between it. Not flame, but silence. And that silence is beautiful, not because it dazzles, but because it welcomes. It makes space for the stars to shine. It makes space for your thoughts to unfold. It makes space for wonder. Scientists once believed that the vacuum of space was truly empty. Now we know that even the emptiest parts of space contain traces of particles, waves, quantum fields. Nothing is truly nothing. Even the coldest silence holds music if you know how to listen. And that music is soft. It's the rhythm of background radiation, the drift of atoms, the slow, invisible spin of galaxies. In the future, when the stars begin to fade and the universe stretches into its final quiet era, there will still be cold. It will deepen, expand, fill every corner. And yet, it will not mean the end. It will mean a new kind of beginning. A universe not in fire but in memory. Not in motion but in stillness. And if anyone is there to witness it, they will feel what you are feeling now. The hush of something too vast to name, the calm of something too old to hurry, the comfort of cold as a final cradle. The quiet between the stars is not a void. It is a cathedral. It is the echo of creation's breath. And every frozen atom, every drifting molecule, every sipping star is part of its slow, holy song. You are part of it too. You carry warmth, yes, but also silence. You carry motion, yes, but also stillness. The same elements that shaped galaxies live in your hands, and the same cold that holds the cosmos now rests softly against your skin. So sleep, if you are ready. Let the cold comfort you. Let it slow your thoughts and steady your breath. Let it remind you that you are not alone in the silence. You are surrounded by it. You are part of it. And somewhere out there between the stars, the universe is holding its breath with you, waiting, watching, whispering. Beautiful things grow in silence. Beautiful things bloom in cold. In the beginning there was not heat, but balance. Not brightness, but symmetry. The earliest moments of the universe were hot beyond comprehension. But it is what came after, the slow cooling, that shaped the cosmos into what we see today. Cold, not heat, is what allows structure to form. It slows particles, stills chaos, and allows the universe to settle into patterns that last. In this way, cold does not chase away energy, it sculpts it. It teaches it where to stay, where to rest, and where to gather. Cold in its silent patience shapes everything. The birth of the universe, the Big Bang, was a moment of unimaginable energy. But that energy didn't last. It stretched, thinned, cooled. As space expanded, temperature dropped. And it was in this cooling that matter began to form. Quarks slowed and clumped into protons and neutrons. Later, electrons joined them. Then atoms. Hydrogen first, then helium. Without cooling, none of this would have been possible. Heat is chaos, cold is invitation. Cold allows bonding, cold allows rest. Over time, as the universe continued to cool, hydrogen atoms began to drift together, pulled by the tiniest threads of gravity. They formed great clouds which collapsed and ignited into stars. But the cold was always there first, making space for gravity to work. If the early universe had stayed hot, everything would have remained scattered. No stars, no galaxies, no planets. Only chaos. Instead, cold arrived like a sculptor with time on its side. It smoothed the fire. It steadied the motion. It waited for light to learn where to go. Even galaxies owe their shape to cold. In the vast distances between stars, space remains cold, near the background temperature of the universe, just a few degrees above absolute zero. In this deep chill, dust and gas can drift undisturbed, forming ribbons and waves. As stars live and die, they throw matter back into this cold sea. That matter becomes the raw material for new stars, new worlds. The cycle continues because cold makes it possible. It preserves the ingredients. It protects the canvas. We often think of the sun as a giver of life, and it is. But what we forget is that the sun's light only matters because space is cold. If the entire universe were hot, sunlight would vanish into it, unnoticed. The reason we see the sun, the reason it warms our skin and wakes the earth, It's because space is so cold. That contrast is what creates meaning. Light only matters when it touches shadow. Warmth only matters when it meets the cold. Some of the universe's most breathtaking structures were formed in cold places. The Eagle Nebula, home of the Pillars of Creation, is a stellar nursery shaped by icy clouds of dust and gas. The Helix Nebula, a dying star's final breath, drifts in a cold vacuum that preserves its delicate rings. These are not places of fire alone. They are places of chill and calm, where change happens slowly, gently. Without cold, such fragile forms would be torn apart before they began. On Earth, we can touch echoes of this shaping cold in the slow geometry of snowflakes, in the crystals of salt that grow from evaporating seas, in the ancient ice that remembers past climates. Cold allows patterns to emerge. It gives matter time to think. In heat, everything rushes. In cold, everything listens. In laboratories, scientists recreate cosmic cold using powerful machines. They cool atoms to near absolute zero, watching how they behave when all rush leaves them. At these temperatures, atoms stop acting like particles. They become waves. They lose their boundaries and merge into something new. These experiments reveal the hidden rules of the universe, rules that are only visible when everything slows down. The closer we come to absolute zero, the more the universe seems to tell us its secrets. There is a kind of elegance to this, that in the quietest, coldest corners of space, the architecture of the cosmos takes shape. Not through violence, but through calm. Not through fire, but through stillness. Cold shapes the cosmos not by force but by patience. It is the painter that waits for the canvas to dry. The wind that carves stone not with strength but with time. The whisper that turns into meaning because it is not drowned by noise. The cold between stars is not absence. It is the frame around the painting. It gives the universe its lines, its textures, its contrast. It makes the stars possible. It makes us possible. Without it, everything would burn too fast, spin too wildly, end too soon. Cold keeps the cosmos alive, not by fueling it, but by tempering it, by holding the fire in place, by giving light a place to land. And so, in the story of the universe, cold is not the villain. It is the artist. It shapes what lasts. It chooses what survives. And it does so not with urgency, but with care. It teaches us that beauty grows slowly, that balance requires stillness, and that sometimes the quietest force is the one that holds everything together. Let us step further into the stillness now, deeper into the role that cold plays not just in structure, but in time itself. In the warm and glowing parts of the cosmos, everything moves quickly. Stars burn through their fuel in fiery lifespans. Gases swirl, collide, explode. But in the cold, everything slows. Time becomes soft, gentle. Things take shape without haste. Galaxies spin not in a rush, but in a slow, graceful dance. The colder a thing becomes, the less it hurries. The more it listens, the more it remembers. Take, for instance, the relic light from the birth of the universe, the cosmic microwave background. This faint glow stretches across all of space, but its warmth is so small it borders on non-existence. Just 2.7 Kelvin above absolute zero, and yet it holds a story billions of years old. The story of the first atoms forming, of space cooling just enough for light to move freely. This frozen radiation is a kind of memory woven into space itself. Not loud, not bright, but patient and eternal. Without the cold, this memory would have been erased, scattered, forgotten. And consider the way gravity shapes cold matter. In warm places, particles bounce and push and scatter. But when gas and dust grow cold, they become cooperative. They settle. They begin to listen to the subtle pull of gravity. It is in this stillness that structure can form. Spiral arms of galaxies curl like frozen waves. Rings around planets hold their shape. Even the Oort cloud, the deep reservoir of comets far beyond Neptune, drifts in a cold so perfect that it has preserved fragments of the solar system's birth for billions of years. They wait in darkness, untouched, until gravity calls them inward. On Earth, deep beneath Antarctic ice, we find neutrino detectors that listen for particles from the furthest corners of space. These particles are so light, so indifferent to matter, that they pass through planets as if nothing were there. But in the extreme cold and clarity of deep ice, their passage can be caught as a brief flicker of light. It is cold that makes this possible. Cold that sharpens our senses, clears the noise and makes rare things visible. Just like in space, it is in stillness that truth appears. Life itself has always had a relationship with cold, not just in survival, but in structure. The double helix of DNA, the most elegant spiral in nature, holds its shape through weak hydrogen bonds, bonds that only remain stable at the right temperature. Too hot, and they snap. Too cold, and life slows too far. But in the narrow window between extremes, life flourishes. Cells move with purpose, proteins fold with care. Even in the deep oceans, near-freezing ecosystems thrive around hydrothermal vents, warmed just enough by the Earth's breath, surrounded by the icy dark. And think of seeds sleeping in frozen soil. Think of embryos preserved in labs. Think of the way memory itself is sometimes easier to recall on a crisp, cool morning than a fevered, heated day. The brain works differently in cold. Some researchers believe mild cooling may protect the brain after trauma, slowing decay, buying time. Cold gives us more than survival. It gives us space, room to recover, room to begin again. In the far future, physicists imagine a universe continuing to expand and cool. Galaxies drift apart, stars die, heat spreads thin. What remains will not be bright, but it may still be beautiful. Rogue planets wandering the dark, black dwarves glowing faintly with memory. And in that chill silence, perhaps new forms will emerge. Not rushed, not loud, but different. Cold creates possibility, not just preservation. Back in the present, scientists use cold to build some of the most sensitive tools ever created. Superconductors lose all electrical resistance when chilled near absolute zero, letting energy flow without waste. Quantum computers depend on near-zero environments to maintain fragile states of information. These technologies don't fight cold, they need it. They use it as a bridge to access realms where normal rules dissolve. In this way, cold is not an obstacle, it is a gateway. Even our understanding of time bends in the cold. In general relativity, time slows near massive objects, black holes, neutron stars. But in thermodynamics, time's arrow is tied to heat. The flow of entropy. As things cool, entropy slows. Systems grow quieter. Order can re-emerge. Cold may not stop time, but it does soften its pace. It gives things a chance to hold their form a little longer, to resist decay, to stay. In the icy rings of Saturn, we see this suspension of time. Tiny moonlets and icy particles orbit for millions of years in near-perfect formation. No atmosphere to erode them, no heat to melt them, just quiet, endless dance. And in the Kuiper Belt, dwarf planets like Pluto remain in frozen solitude, tracing their paths through the edge of sunlight, unchanged for eons. Cold reveals the patience of the universe. It shows us that not all beauty comes from violence or heat, that there is elegance in stillness and wisdom in waiting, that cold is not absence but potential, a silence not of despair but of readiness, the way a forest feels before dawn, the way the sky holds its breath before snow. So when you imagine the cold parts of the cosmos, those faraway stretches between galaxies, those blackened remains of dead stars, those drifting comets, do not see them as dead. See them as watching, holding, becoming. The universe does not rush. It has all the time it needs, and cold is the keeper of that time, the guardian of its slow and silent song. The more we understand this, the more we can see ourselves within it, our own need for pause, for sleep, for deep thought, for peace. Cold reminds us that speed is not always strength, that motion is not always meaning, that in stillness too there is life. Let yourself rest now in the idea that cold is not the absence of energy, but the art of conserving it. In the grand architecture of the cosmos, it is not flame that builds foundations, but frost. Stars burn, yes, but they are born in cold, they die into cold, and their scattered remains travel through cold to begin again. This cycle is ancient, endless, and entirely dependent on stillness. Without cold, the heat would never have a chance to mean anything at all. It is easy to think of the universe as a place of constant motion. Explosions, collisions, flashes of light. These are the stories we often tell, but they are only part of the truth. Beneath all that movement is a quiet underlayer, a framework of slowness. Cold provides that framework. It holds the tempo, it keeps the rhythm steady. It gives the bright event something to return to, a place to rest, a place to begin. Consider again the moment after the Big Bang when everything was fire and light. In that chaos, nothing could last. It was only as the universe expanded and cooled that atoms formed, matter gathered, and the great cosmic structures began to grow. From this cooling came galaxies, stars, planets, and us. Our very bodies are built on the chemistry that cold allowed to unfold. Carbon chains, water molecules, helical strands of DNA. All of these needed time, quiet, and cold to take shape. And just as cold shaped the beginning, it will shape the end. One day the last stars will burn out. The last white dwarfs will fade. Black holes will evaporate. What will remain is not noise, but silence. Not heat, but the long, slow breath of a universe settling into memory. Scientists call this idea heat death, not because everything is on fire, but because energy has thinned so far across space that nothing can change anymore. The universe, cooled to near perfection, becomes still, not dead, just finished. And perhaps that isn't frightening, perhaps it is beautiful, to think that after all the movement, all the births and collapses and spirals of time, the universe will rest. Cold will be the last voice. It will speak not in sound, but in shape, not in force, but in balance. It will not demand anything. It will simply be there, soft, dark, complete. Meanwhile, here on Earth, we carry a small piece of that cosmic stillness within us. Our bodies, though warm, are shaped by the physics of cold. Our world, though alive with weather and breath, depends on the cold void that surrounds it. We live between heat and ice, between fire and silence, and in that narrow band we flourish. But we forget sometimes how fragile that balance is, how much of our world depends on the cold staying where it is, holding space for the warmth to thrive. We see this balance in every glacier, every winter, every breath that leaves our lips as mist. Cold is part of life's design. It teaches us about limits, about patience, about the power of pause. When we cool things, whether it is metal, air, or our own thoughts, we give them shape. We stop the rushing. We make room for detail. Cold allows meaning to settle. Think of music. The rests are as important as the notes. The silence is not the absence of song, it is what makes the song possible. Cold is like that, a cosmic rest, a long, steady breath that lets the universe catch itself. And in that breath, entire galaxies are born. So when you look up at the sky, try not to see only the stars. See the space around them, the darkness, the cold. That is where the story lives. That is what makes the light matter. Every beam from a star travels through cold to reach you. Every comet's arc is drawn by it. Every planet's orbit balances within it. Cold does not chase heat. It holds it. It gives it contrast. It defines its shape. This is why the coldest places in the universe are also the most beautiful. Not because they sparkle or shine, but because they wait. They don't rush. They don't compete. They simply exist, in full trust that time will reveal their meaning. In this way, the cold teaches us the quietest kind of wisdom, the kind that needs no words, the kind that lives in the space between things. And maybe that's what the cosmos has been trying to say all along, that we do not need to burn to be bright, that we do not need to rush to be real, that stillness is not emptiness, it is awareness, it is calm, it is depth. Let that thought settle into you now. Let the quiet come in, let the cold bring clarity, not fear. Let it remind you that even in the vast and frozen reaches of space, the universe is not abandoned. It is resting, becoming, watching. And you, in your quiet body, your warm breath, your soft presence, you are part of that grand, slow unfolding. So close your eyes if you wish. Feel the hush. Feel the peace that cold provides. Not the kind that stings or harms, but the kind that steadies. The kind that shapes. The kind that lasts. And know that somewhere in the deep stillness between galaxies, the cosmos holds you in its cold, careful hands. That is how cold shapes the cosmos. Not loudly, not quickly, but completely. There is a point so cold, so still, so utterly silent that even the idea of movement begins to fade. Scientists call it absolute zero, 0 Kelvin, or minus 273.15 degrees Celsius. But beyond the numbers, beyond the equations and instruments, it is something more, a threshold, a boundary not just between temperatures, but between worlds, the world of motion and the world of pause, the world of energy and the place where energy almost vanishes. This is the heartbeat of absolute zero, not loud, not fast, but impossibly slow, soft, steady. A beat so faint that it is nearly lost to time. We cannot truly reach it. No matter how carefully we cool, how deeply we isolate, how delicately we design our traps and vacuums and lasers, absolute zero always stays just beyond touch. It is not a destination. It is a direction, a point the universe gestures toward but never arrives at. Still, we try. And the closer we get, the more beautifully strange things begin to happen. Atoms forget their individuality. Matter begins to whisper in waves. Particles blur into clouds, and the universe lets us see how it behaves when all its energy lies down to rest. At room temperature, the world is a hum of motion. Molecules vibrate, electrons dance. Even in your skin, in your breath, in your bones, trillions of atoms are constantly moving, colliding, bouncing with heat. But as we cool, those vibrations slow. Bonds stiffen. Paths straighten. The hum softens to a murmur. And when we reach the edge of absolute zero, almost all movement stops. Not because the atoms disappear, but because they are finally at peace. This stillness is not death. It is clarity. It is order. It is potential. Imagine a pond in late autumn, frozen so completely that not a ripple remains. Underneath, everything is preserved. Every leaf, every stone, every branch, exactly where it was, untouched by time. This is what absolute zero offers, a stillness so perfect that information cannot slip away. It is a window, clean and clear, through which we can glimpse the true structure of matter. In these extreme temperatures, something beautiful unfolds. Bose-Einstein condensates. This exotic state of matter, predicted by Einstein and Bose in the early 20th century and created decades later in labs, happens when particles known as bosons are cooled to just above absolute zero. Instead of bouncing separately, they begin to act as one. They lose their boundaries. Their individual identities melt into a shared existence, a superatom, spreading out like a fog of possibility. It is not magic. It is physics at rest. A kind of cosmic sigh expressed through chilled perfection. These condensates are fragile. The slightest heat destroys them. But in their brief lives, they teach us something profound. That when motion slows, unity increases. That simplicity emerges from stillness. That the closer we come to absolute zero, the more deeply we understand how the universe holds itself together, not through speed or heat, but through coherence, through calm. In the laboratory, achieving these temperatures is like sculpting air. Scientists use magnetism, lasers, and vacuum chambers to coax atoms into stillness. They cool clouds of gas, not with ice but with light, laser cooling where photons gently slow atomic motion. Each step is a dance of patience, each degree fallen is a moment of greater quiet. And when the temperature drops near that final barrier, everything changes. The laws we thought we knew begin to shift. Matter becomes poetry, even superconductivity, a phenomenon where electricity flows without resistance, relies on deep cold. In metals cooled to critical temperatures, electrons pair up and move as one. No friction, no heat lost, just pure silent current. It is as if the material, once chaotic, has learned how to breathe together. Cold allows that, absolute zero invites it. Beneath the threshold of noise, order blossoms, and yet even here the heartbeat continues. For as silent as it becomes, the universe never truly sleeps. Quantum rules forbid complete stillness. Even at absolute zero, particles flicker with something called zero-point energy, a tiny, irreducible tremble. This is the final heartbeat, the last breath of motion, the whisper that can never be silenced. It is not chaos, it is a promise, that even in the coldest silence something stirs. This zero-point energy is what keeps atoms from collapsing into nothing. It's the quiet breath of a vacuum, the silent presence in a place we thought was empty. It reminds us that the universe is never fully at rest, that creation, however paused, never truly stops. In the coldest corners of physics, life persists, not as flame but as pulse, Absolute zero, then, is not the end of the story. It is the quiet beginning, the first breath before all others, the foundation on which motion builds. The universe began in heat, but it is cold that reveals its design. And at the heart of that cold lies something tender, something true, a beat, a rhythm, a sense that even the stillest places carry meaning. So when we chase absolute zero, not just with instruments but with imagination, we are not fleeing warmth. We are seeking understanding. We are moving closer to the point where energy hums its softest note. And in that softness, we find something precious, something pure. The heartbeat of absolute zero is not a sound you can hear. It is a stillness you can feel. It is the universe whispering, "I am here. I am quiet. I am whole." Let us drift deeper now into the quiet mysteries that surround absolute zero, not as a limit, but as a landscape, a place where the rules of nature, so familiar at higher temperatures, begin to soften, bend, and transform. In this world of near zero, atoms no longer behave like tiny billiard balls. Instead, they spread, blur, and ripple like waves. They lose their sharp edges and begin to behave not as individuals, but as echoes of something larger. This transformation is not just physical, it is poetic. It reminds us that the universe is not made only of particles, but of patterns. And at the edge of absolute zero, those patterns come into view like frost forming on glass. To understand this strange world, we must remember that temperature is not a substance, it is a measure of motion. The faster atoms move, the hotter the material. The slower they move, the colder it becomes. But what happens when you slow them nearly to a stop? What remains when motion is gone? The answer is not nothing. The answer is something new, something hidden in the fabric of quantum reality. At these chilling depths, nature begins to whisper its most delicate truths. One of those truths lies in superfluidity. When certain substances, like helium-4, are cooled below a critical temperature, they begin to act in ways that defy all intuition. The liquid flows without friction. Spill it in a dish and it climbs the walls, stir it, and it swirls forever. There is no resistance, no loss, no slowing down. It is as if the fluid forgets it is made of atoms and becomes something else entirely, a smooth, continuous dance. The cold does not freeze it. The cold frees it. In this state, the fluid becomes a kind of memory of perfection, a mirror of motion without waste. Superfluids reveal a truth that runs through many cold phenomena, that stillness and unity are deeply connected. As temperatures drop, the messy individuality of particles gives way to collective behavior. Electrons pair up in superconductors, bosons gather in condensates, fluids become one body. It is as if the universe, under the calming hand of cold, decides to stop arguing with itself. It chooses harmony over heat, order over noise. This harmony extends to quantum coherence. In warm environments, particles are easily disturbed. They decohere, they forget their shared state, collapse into randomness. But at low temperatures, coherence is preserved. Particles remember their entanglement, their synchrony. Quantum computers built to harness this coherence require extreme cold to function. Without it, their delicate quantum states would vanish in an instant. Cold is not just helpful, it is essential. It holds the quantum world together like a careful breath, quiet and exact. And it is not only particles that transform in the cold, it is also time. In warm systems, time rushes forward, pulled by the arrow of entropy, of increasing disorder. But in cold, entropy slows. The forward push of time becomes gentle. Processes stretch, reactions pause, decay is delayed. It is as if time, too, needs warmth to rush, and without it becomes a slow, circling stream. In this way, near absolute zero, we do not only see matter behave differently, we see time itself soften. Deep inside neutron stars, some of the coldest and densest places in the cosmos, matter is crushed and chilled to extremes. The core may be just a few degrees above absolute zero, even as gravity squeezes particles into forms we cannot reproduce on Earth. There, in those frozen hearts, quarks may flow like a superfluid. Nuclei may arrange in crystal lattices. These stars do not burn, they remember. They are the fossils of ancient explosions, holding the cold secrets of collapsed suns. Even black holes, those dark gravitational wells, may contain cold mysteries. While their surfaces blaze with energy, the space just outside them, the event horizon, is thought to radiate faint cold light known as Hawking radiation. This radiation comes not from heat, but from quantum trembling in the vacuum of space. A reminder that even in darkness, even in silence, even in the absence of matter, the universe stirs with ghostly energy, a beat that never quite fades. Back in our laboratories, the pursuit of colder and colder temperatures continues, not for novelty, but for understanding. Each new step closer to absolute zero unlocks another door. We discover new phases of matter, new behaviors, new truths. We see the universe not in its fiery beginnings or explosive moments, but in its still waiting state. We study how order emerges, not through force but through stillness, not through fire but through frost. This pursuit is not only scientific, it is philosophical. It asks us to imagine a world where noise has been set aside, where motion has been muted, where the wholest, quietest forces can finally be heard. Cold is not a punishment, nor a failure of energy. It is the condition under which subtlety thrives. It reveals the hidden language of nature, the soft grammar beneath the shouting of heat. And in this quiet, we find ourselves. Human beings, warm-blooded and fragile, are creatures of warmth, but we are also dreamers of cold. We cool our instruments to see more clearly. We chill our thoughts to reflect more deeply. We seek the clarity that stillness brings. Absolute zero may be unreachable, but it is not unknowable. It lives in our experiments, our metaphors, our memories of winter air. It is the mirror at the end of energy, showing us not how things burn, but how they rest. So when we imagine the coldest point in the universe, let us not think of lifelessness. Let us think of listening, of pausing, of becoming aware. For the heartbeat of absolute zero is not the absence of life, it is the awareness of its structure. The universe laid bare, clean, quiet, beautiful. Now let us drift toward the conclusion of this journey, into the heart of stillness, where cold is not an enemy but a guide. Absolute zero is often imagined as a void, an end, a place so empty it erases everything. But the deeper you understand it, the more you begin to see that it is not the end of energy, it is the origin of balance. The heartbeat of absolute zero is not about silence as emptiness, but silence as presence. It is the hum of the universe when everything unnecessary has been set aside. It is the simplest rhythm of being. At absolute zero, we see the blueprint of the cosmos. When atoms stop moving, they stop distracting us with motion. What's left is structure, pure, undisturbed, essential. And it's in that structure that we begin to notice how deeply connected everything is. The same particles that danced in the early fire of creation now rest together in collective calm. The same forces that shaped galaxies in the heat of chaos are still present here, in this chilled quiet. They haven't vanished, they've been revealed. And even in this stillness, something always stirs. Zero-point energy is the last secret the universe keeps close, is the proof that nothing is ever fully at rest. That even when heat has drained away and motion has slowed to nearly nothing, there is always a flicker, a shimmer, a soft quantum breath. And that flicker, that breath, is enough. Enough to hold space open, enough to shape possibility, enough to ensure that the story doesn't stop. The heartbeat of absolute zero is steady, not because it is loud, but because it never leaves. It is with us always, in the way electrons orbit, in the way superconductors flow, in the way matter becomes a wave at its calmest. It is the foundation beneath every calculation, every observation, every experiment. It's the background hum we don't always hear, but always depend on. Without it, we could not know the contrast that defines the universe. We would not see light without dark. We would not feel motion without pause. We would not know warmth without the quiet of cold. Somewhere in the deep future, long after the stars have cooled and the galaxies have drifted apart, the universe will slow. There will be no more fiery births, no more radiant explosions. What remains will be cold, a quiet field stretched across infinite space. But in that cold we will not find nothing. We will find memory, the imprint of everything that was, the map of particles still gently trembling in zero-point dance, the echo of all the life that once flickered in warmth. That final state of the universe may be cold, but it will be full of stories etched into its fabric. And perhaps that is what makes absolute zero so beautiful. It is a state that holds everything, not through grasp, but through stillness. It does not capture, it does not control, it simply holds, it waits, it preserves. And through that waiting, it offers clarity. We chase this temperature not just to freeze atoms, but to freeze time, to stretch it long enough that we might glimpse what lies beneath all noise. There is wisdom in this. We live in a world that runs hot, with speed, with urgency, with noise. We often forget the value of pause, of slow breath, of still thought. But cold reminds us. It teaches us that life does not only happen in heat. That revelation can come in quiet. That depth is not always created in movement. It is discovered in rest. The nearer we move toward absolute zero, the more carefully the universe begins to speak. In your own life, you've felt this too. A winter morning where every sound was muffled by snow. A moment of silence in a dim room when your breath seemed the only thing alive. A walk through cold air that brought clarity to your thoughts. These are not accidents. They are echoes. Echoes of a deeper truth. That cold is not a force against you, but a rhythm around you. A reminder to slow down, to listen, to feel. The science of cold is precise, technical, exacting. But the poetry of cold is universal. It tells us that in the deepest silence there is order. In the softest stillness there is truth. Absolute zero, unreachable though it may be, is a guidepost, a symbol of what happens when we remove everything unneeded. What remains is not absence, it is essence. So if you ever find yourself seeking understanding, seek the stillness first. If you want to know how things hold together, look for the places where they do not rush. If you want to hear the most honest voice in the universe, listen in the coldest hour, for it is there where the universe lets down its noise that you will hear it. That soft, steady rhythm, that quiet pulse, that heartbeat of absolute zero, reminding you there is peace in stillness, there is unity in calm, and there is beauty in the cold that holds it all together. There is a moment in the story of matter where light begins to slow, not in space where it moves freely across the vacuum, nor in the warmth of stars where it blazes without restraint, but in the coldest corners of the lab, in clouds of atoms cooled near absolute zero, something astonishing happens. Light, that swiftest traveller, begins to pause, not because it is trapped, but because the world around it has grown so calm, so perfectly ordered, that even light has to listen. This is the world of Bose-Einstein condensates, a place where matter forgets its boundaries and becomes a quiet shared dream. It is not just physics, it is beauty, slowed into being. To understand this, we begin with heat. In our ordinary world, everything is warm enough that atoms move constantly. They jiggle, bounce, collide. Each particle behaves on its own, like dancers in a busy crowd stepping to their own rhythms. But as you cool them, the chaos fades. The dance becomes more careful. The collisions grow rare. And when the temperature falls to a fraction of a degree above absolute zero, something extraordinary unfolds. The particles begin to move not as many, but as one. This is the Bose-Einstein condensate, first predicted nearly 100 years ago, but only created in labs in the 1990s. In this state, certain atoms, those that follow the rules of quantum sameness, sink into the lowest energy level available. Instead of acting like individuals, they merge into a single quantum state, a fog of unity, a shared existence where identity blurs. If you could see it, it wouldn't look like a crowd, it would look like one slow, perfect breath, and into this breath scientists shine light. Normally, light moves at an unfathomable speed, about 300,000 kilometers per second in a vacuum. Even in glass or water it slows only slightly. But in the heart of a Bose-Einstein condensate, that same light may crawl along at just a few kilometers per hour, or slower, or even stop entirely. Not because something blocks it, but because the condensate has become a kind of dream space. The atoms, so deeply in sync, create conditions where light cannot pass without permission. It enters gently, curls up in the stillness, and waits. This slowing of light is not a trick. It is a glimpse into the way the universe behaves when all distractions are gone. When heat and noise and randomness fall away, the deeper layers of reality come forward. In the condensate, light becomes not just a wave, but a partner in the quiet. It does not blaze. It listens. And the atoms, cooled nearly to silence, sing in ways they never could before. Bose-Einstein condensates are rare, fragile. They exist only for moments in carefully shielded chambers, surrounded by machines that hum with precision. But in those moments, they offer more than data. They offer insight. They show us that nature, when allowed to rest, reveals an order far deeper than what we see in daily life. The hot, fast universe we know is only one layer. Beneath it lies a cold, coherent world of waves and whispers. Inside this world, strange things happen. Matter acts like light. Light acts like matter. Boundaries soften. Particles interfere with themselves, creating ripples and patterns that echo not just through space but through time. The condensate does not tell atoms where to go. It becomes the place they are. There is no edge, no border. Only gentle probability, spread like mist over a morning field. This unity is not limited to one type of atom. Scientists have now created condensates from rubidium, sodium, lithium, and beyond, each one with its own character, its own form of harmony. And as they learn to manipulate these clouds, researchers are discovering new forms of behavior: quantum vortices, atomic solitons, and waves that move without losing shape. These are not just curiosities, they are hints, signs that the universe contains more languages than we thought, and many of them are written in cold. When we think of matter, we often picture solidness, mass, resistance. But a Bose-Einstein condensate is not solid. It is not hard, it is not firm, it is soft like a sigh, like a shadow. It flows, it drifts, it remembers being many particles, but no longer insists on separation. It chooses togetherness. In this way, it becomes something that feels almost emotional, a gathering of what once was scattered, a return to unity. The slowing of light in this space is not just a marvel, it is a metaphor. In our fast-moving world, we often race past the quiet truths, but here, even light must pause. Even the fastest thing in existence finds itself moving gently. It bends, it listens, it becomes part of the stillness. And in doing so, it reveals something tender, that there is power in slowness, that clarity comes not from speed, but from calm. This is what Bose and Einstein saw so long ago, not a fantasy but a possibility, that if we cooled the world enough, we might uncover its deepest rules, not the rules that shout, but the ones that whisper, not the ones that burn, but the ones that breathe. And now, in labs across the earth, those whispers are being heard, those breaths are being measured, those dreams are becoming real. So let us imagine this space together, a chamber filled with invisible fog, atoms no longer moving apart but together, light entering like a guest, not a conqueror. The world so quiet, so slow, so united, that even time seems to pause. This is not science fiction. This is now. This is a kind of cold that doesn't freeze. It opens. A cold that does not end motion but refines it. A cold that makes beauty visible. And this is just the beginning. The light has slowed. The fog has formed. The breath has begun. Let us drift further now into the quiet fog where matter becomes a memory of itself, and light, so used to racing forward, learns the rhythm of rest. In this strange and delicate realm of Bose-Einstein condensates, we are not simply looking at a state of matter, we are listening to a deeper language. The language of unity, of coherence, of time slowed not into silence but into song. For as the temperature falls and the particles lose their urgency, what remains is not less, it is more connected, more precise, more beautiful in its stillness. In the normal world of matter, even a single drop of water contains chaos. Every molecule moves at its own pace. They bounce and twist and dart in unpredictable ways, but inside a Bose-Einstein condensate there is no darting, no bouncing, no competition. The atoms move in harmony. If one turns, the others turn. If one drifts, they drift together. It is not like a school of fish or a flock of birds following a leader. It is deeper than that. It is sameness at the level of existence, not imitation, identity. This shared identity gives rise to something called quantum phase coherence. It means that the atoms are not just together, they are in sync. Their quantum states, which usually differ wildly, collapse into a single shared state. And in that shared state, the boundaries between them dissolve. The condensate becomes a single wave, smooth and undivided. You cannot point to one atom and say, there it is. You can only feel the presence of the whole. It is like hearing a single tone and knowing it comes from many voices that no longer sing alone. This coherence makes Bose-Einstein condensates incredibly sensitive. The slightest disturbance, a flicker of heat, a breath of motion, can ripple across the whole. They feel as one, they respond as one, and in this responsiveness lies their potential. Physicists are exploring how to use them as sensors, as quantum tools, as windows into the deepest structure of reality. They may help us measure gravity more precisely, map magnetic fields with new accuracy, or even peer into the quantum structure of space itself. But the condensates do not reveal their secrets quickly. They must be coaxed into being layer by layer. Scientists begin by trapping a cloud of gas, perhaps rubidium or sodium, and then cooling it with laser light. The light is tuned just right, so that each photon pushes the atoms slightly, slowing them down without heating them up. Once they're cold enough, magnetic traps take over, isolating the slowest atoms and letting the faster ones escape. What's left behind is a quiet core, a place where energy nearly vanishes, where particles remember they are waves. It is here in this final stillness that light enters. The light does not blaze, it bends, it waits, it becomes part of the condensate's calm. Scientists can manipulate this interaction, using pulses of laser light to store information in the condensate like writing in fog. The information is held not in hot circuits, but in chilled atoms. It is a new kind of memory, quantum memory, made possible only by slowness, by silence, by cold, and when light slows in this fog, something profound occurs. It compresses. The wave becomes shorter, more concentrated. This means that even a small volume of condensate can hold more information than the same space could in the warm, rushing world. The light does not just move slower, it moves more wisely. It learns to take up less space, to be more precise. In the calm, it becomes thoughtful. This interaction opens new possibilities for quantum computing and communication. Scientists dream of building networks where information travels as light, but is stored in condensates, slowed, shaped, and held with care. These systems would not burn with energy like today's machines. They would hum softly, gently, like a library of light kept cool in a bowl of quiet atoms. And it is not only light that learns to behave differently here. Matter itself begins to exhibit patterns that cannot exist at higher temperatures. Solitons, single self-sustaining waves, can travel through the condensate without fading. Vortices can spin, forming tiny whirlpools of quantum flow. These structures, while invisible to the eye, carry the fingerprints of deeper laws. They are the marks left behind when the universe whispers instead of shouts. In observing these marks, we begin to understand that the condensate is not a thing, it is a place, a condition, a doorway into a version of reality that always exists, but is usually hidden beneath the noise. Most of the time, heat masks it, movement smears it, but in cold it becomes visible, tangible, real. The beauty of this is not just in the physics, it is in the metaphor, that when things slow down, when movement eases and chaos rests, truth appears. That unity is not a byproduct of force but of calm. That coherence, the state of being in perfect rhythm, arises not from shouting over one another, but from listening together in silence. So the Bose-Einstein condensate is more than a scientific wonder. It is a lesson. It teaches us that slowness is not weakness, that in stillness, complexity is not lost, it is revealed, and that sometimes the most meaningful changes happen when everything seems still. Let this idea settle within you. Imagine the world cooled to stillness, particles drifting together, light pausing mid-flight, the universe quiet enough to think, and in that quiet new possibilities begin, not because something was added, but because everything unneeded was let go. That is what cold does. That is what this condensate becomes. Not a container of energy, but a sculpture of calm, a fog where light can learn to listen, a breath where matter finds its reflection, a moment where the universe reveals its softest truths. Now let us rest in the final part of this journey, where the light has already slowed, where the atoms have already gathered, and where the quiet hum of coherence fills the air. The Bose-Einstein condensate is no longer an experiment, it is a presence, a moment suspended in cold. It is the universe reduced to its softest motion, its calmest breath. Here, in this space of near-perfect stillness, we are invited not just to observe, but to feel what it means for matter to forget its separateness, for light to surrender to its speed, for time itself to unfold like a slow tide washing gently over the shore of reality. This is not an ending. It is a beginning in disguise, a new lens through which to view what is possible when things are allowed to settle. In the ordinary world, we rely on pressure and force to shape matter. We push, we pull, we burn. But the condensate shows us another way, a path shaped not by action but by patience. In this delicately cooled cloud of atoms, everything that once collided now moves in harmony. And harmony, it turns out, is not rare, it's simply quiet. Within this harmony, scientists are discovering behaviours they never expected. Condensates can behave like waves and particles at once. They can tunnel through barriers, interfere with themselves, and occupy places not with presence but with possibility. It's a world where reality becomes soft-edged, not from uncertainty, but from gentleness. Each observation we make does not only reveal truth, it changes it. The condensate is not frozen in time, it is time briefly cradled in balance, and perhaps the most poetic truth of all is that this balance cannot last. The condensate, once formed, is already preparing to dissolve. The heat from the outside world, the vibrations of the laboratory walls, the photons of stray light, all begin to creep in bit by bit. The atoms warm, their unity weakens, their individuality returns, the breath ends, the fog lifts, and the world resumes its faster pace. But something lingers. What lingers is not the condensate itself, but the memory of it. The knowledge that deep within matter is this capacity for peace, that beneath the rush of everyday life, the jostle of thermal energy, the chaos of constant change, there is a layer of being that remembers how to be still, that remembers how to act as one. This knowing changes us. It changes how we build machines, how we study time, how we think about information and energy and light, and it changes how we see the world. We begin to see stillness not as absence but as potential. We begin to understand that there is value in slowing down, not just for particles, but for people. That deep coherence, whether between atoms or ideas, requires quiet. It requires trust, and it cannot be rushed. The Bose-Einstein condensate, with all its fragile elegance, becomes a symbol, not of cold for its own sake, but of what can happen when heat fades and connection grows. In the far future, perhaps long after our current technologies have transformed beyond recognition, condensates may be used to store thought itself. Quantum memories encoded in stillness. Networks that pulse not with electricity but with cooled light. Instruments that measure not by resistance but by resonance. In such a world, the fastest computers may be the quietest. The most powerful devices may be those that rest closest to stillness. Even now, in some of the world's coldest laboratories, researchers are exploring quantum entanglement within these condensates. Spooky connections that defy space, where two particles share one state across distance. The idea that distance does not matter, that two things can be one even when apart, begins to feel not just scientific but deeply human. Unity across space, a harmony beneath motion, connection even when silence stretches between us. This is what Bose and Einstein hinted at so long ago, that cold was not the enemy of energy, but the artist of form. That when things grow calm enough, the truth of their connection becomes visible. And now, with every condensate formed, we get closer to seeing that truth not just in equations, but in experience. So now, imagine yourself standing at the edge of one of these experiments. There is no sound, no light flickering wildly. Just a cloud, dim, nearly invisible, floating in a vacuum chamber, chilled beyond breath. The atoms are not fighting, they are flowing. The light is not rushing, it is listening. And time, for a moment, has learned to move slowly. In that stillness you realize, this is not just a moment of physics, this is a portrait of the universe relaxed, a glimpse of how everything behaves when it is allowed to rest. And perhaps if you listen closely, you'll hear your own self in that silence, your own breath slowing, your own thoughts settling. Because the story of the Bose-Einstein condensate is not only the story of atoms, it is the story of balance, of what we find when we are not pulled in every direction, of the beauty that rises when we surrender to the calm. The light has slowed, the matter has merged, the fog has cleared, but the lesson remains. Stillness is not the end of movement. It is the shape that movement takes when it is at peace, High above the warmth of planets, far beyond the glow of stars, something quiet is happening. In the coldest reaches of interstellar space, where light is faint and time flows like a slow river, ice begins to form. Not the ice of winter puddles or frozen lakes, but cosmic ice, crystals shaped in darkness, grown in silence, built one atom at a time. These crystals do not decorate, they create. They are the architects of planets, the sculptors of stars, the hidden builders of galaxies. And though they are nearly invisible, their touch is everywhere. For in the great cold beyond the suns, it is ice that remembers how to hold things together. When we look up at the night sky, we often see light. Distant suns, glowing nebulae, trails of comets. But between those lights, in the darkness that seems empty like clouds of dust and gas, vast, slow-moving swathes of matter so cold that even atoms barely move. These clouds are where stars are born, and inside them grains of dust, tiny ancient fragments of rock and metal, serve as the seeds. Around these seeds, water molecules gather. They cling, freeze, and form layers. And so in the quietest places, ice begins its patient work. Cosmic ice is not like the ice we know. It forms under different pressures, different rules. In the vacuum of space, where no wind blows and no sound travels, water freezes into fragile, lacy structures. It wraps around particles of carbon, of silicate, of iron. It builds shells, it traps gases, it holds stories, and over time these icy grains begin to drift together. They collide, not violently, but gently, like snowflakes brushing in the air. They stick. They grow, and from these icy clumps, something larger begins to form. Planets begin this way, not in fire, but in frost. Before Earth had oceans, before comets brought water to its surface, before atmospheres breathed or tectonic plates moved, there was ice. Ice in the early solar disk. Ice in the tails of wandering comets. Ice wrapping tiny grains, helping them stick together. Without it, the dust might never have become stone. The stone might never have become worlds. But the story does not end with planets. Even stars, those fiery beacons of fusion, begin in places where ice still clings. Before a star is born, it exists as a dense core inside a molecular cloud. In these cores, temperatures are so low, just a few degrees above absolute zero, that water freezes onto dust. The cold preserves everything. Molecules do not break apart. Complex chemicals, including the building blocks of life, form and remain intact. When the core collapses and heat rises, much of this ice is vaporized, but not before it has seeded the environment with possibilities. In this way, ice is a kind of messenger. It carries history through space. It shields fragile molecules from radiation. It preserves ingredients that, when warmed, may awaken into biology. On comets, on the moons of Jupiter and Saturn, on the shadowed craters of Mercury and the Moon, we find ancient ice, unchanged for millions, even billions of years. It is a time capsule, a map, a song frozen into crystal form. Ice too creates beauty. The rings of Saturn gleam because of ice, millions of particles coated in frozen water, dancing in the cold shadow of the planet. The glints of comets, the reflections in distant nebulae, the pale halos around stars, all owe something to ice. It does not glow on its own, but it reflects, it shapes, it bends light gently, it softens the cosmos, it gives form to its silence. On Earth, we see only a glimpse of this cosmic role. Snowflakes fall, no two alike, each one a brief miracle of geometry. But high above, in the cold between the stars, ice forms patterns even more delicate, microscopic, fractal, persistent through time. Telescopes have begun to detect these frozen molecules, finding traces of water ice, methane ice, ammonia ice on distant worlds and within dark clouds. And each detection tells us, life may be possible. Water may be present. Memory may be preserved. It is strange to think that something so familiar, ice, is also one of the universe's oldest and most widespread sculptors. But that is the nature of stillness. It hides its strength behind quiet. It works solely but completely. It needs no spotlight, it needs no noise, it simply gathers, holds, builds. And in the deepest cold, when particles slow to a near halt, ice keeps forming. Not because it is forced to, but because the laws of nature bend in its favour. Water, so wild and fluid at room temperature, becomes precise. It arranges itself. It crystallizes. And in doing so, it creates stability. It locks in structure. It makes possible the slow, fragile work of building something permanent. Without ice, the dust might blow forever through space. Without it, gravity might have too little help. But with it, things come together. They cohere. They pause long enough to become something more. And in that pause, in that stillness, galaxies grow. So now, when you look up at the sky, try to imagine the invisible crystals drifting there. Not just as relics of cold, but as builders of everything. Imagine the breath of water, frozen into stillness, shaping stars from dust, forming moons from mist, protecting the fragile ingredients of life. Ice is not only a product of cold, it is the purpose of it. It is what cold makes possible, and it is, in its quietest form, a kind of creation. In the beginning there was light, but before the light could shine there had to be structure, and that structure was built in the dark, in the silence, in the cold, by crystals in the sky. Let us continue now, following the gentle trail of frozen breath that extends across the cosmos. In the dark reaches of space, ice is not merely an echo of cold, it is an agent of change. It acts not through force, but through patience. It connects the smallest particles to the largest structures, shaping worlds with nothing more than time and stillness. In this way, ice becomes something more than a frozen state of water. It becomes a blueprint, a soft architecture that the universe uses to hold itself together. Inside molecular clouds, where starlight cannot reach, and temperatures fall to just a few degrees above absolute zero, ice is constantly forming. Every tiny grain of dust becomes a canvas for molecules to settle upon. Water is the most common, but not the only artist at work. Carbon monoxide freezes, methane, ammonia. Even more complex compounds, alcohols, acids, simple sugars, can be found in these frozen mantles. These aren't just chemicals, they're precursors, the seeds of organic chemistry resting in frozen patience. Over time, as these grains collect into denser clumps, the ices begin to shape the chemistry of young planetary systems. When the heat of forming stars begins to warm their surroundings, the ices melt and evaporate, releasing gases into the forming atmospheres of planets. This process, called outgassing, helps form the thick air of worlds like Earth, Venus, and Mars. Without ice to trap and carry those ingredients, many planets might remain dry, barren, breathless. Ice also governs where different types of planets can form. In the early solar system, a boundary called the frost line divided the inner rocky planets from the outer gas giants. Inside this line, the sun's warmth kept water in vapor form, preventing large icy bodies from forming. But beyond the frost line, water and other volatiles could freeze. Icy grains were more common, allowing larger clumps to form, and eventually the cause of gas giants like Jupiter and Saturn. Ice gave them their mass, their gravity, their identity. Even today, those outer worlds are rich with ice. The moons of Jupiter, Europa, Ganymede, Callisto are wrapped in it. Saturn's Titan is coated with frozen hydrocarbons, its rivers and lakes not made of water, but of methane and ethane. Neptune's moon Triton, Pluto and its companion Charon, the dwarf planet Eris, each is a museum of ancient ice unchanged for eons, preserving a chemistry that began before the sun was born. And beneath these frozen shells, something astonishing may lie. Oceans. Not frozen solid, but hidden beneath miles of ice, warmed by the faint pull of tidal forces or radioactive decay. These oceans, dark and unbearded, may harbour life. Not the kind we know, but life shaped by silence. Life that listens to the cold. Ice doesn't just build the outside, it may be hiding the inside, the soft, secret worlds waiting beneath. The same principles scale upward. In the hearts of galaxies, clouds of dust and ice drift for thousands of light years, forming stellar nurseries. Ice binds these particles, shields them from radiation, and allows them to survive long enough to become stars, solar systems, and eventually, maybe life. The shapes of these clouds, filaments, arches, knots, are carved in part by the stickiness of ice, the way it lets matter hold hands, even in the dark. And ice carries memory. It holds gases trapped for billions of years. It preserves isotopic ratios that tell scientists where the molecules came from. In Antarctic ice cores, we read the story of Earth's past climate. On comets, we read the story of the solar system's formation. In icy grains around newborn stars, we read the story of galaxies building themselves slowly, molecule by molecule. In recent years, telescopes like ALMA and the James Webb Space Telescope have begun detecting the spectral fingerprints of ice in places we could only imagine before, around infant stars, in the disks that will one day become planets, in distant galaxies just beginning to form. They see water ice, carbon dioxide ice, even ammonia and methanol ices, silently layered on dust grains drifting in the void. The more we look, the more we find. The universe, it turns out, is frosted with possibility. Ice also reflects light in a way that creates some of the most ethereal sights in the cosmos. The bright coma and tails of comets are not the comet itself, but sunlight reflecting off gas and ice released as it nears the sun. The halos seen around stars and planets are often created by high-altitude ice crystals. Even the blue glint of Earth, when viewed from far away, owes something to frozen clouds. Ice makes the invisible visible. It gives shape to light. And in its stillness, ice shapes time, because it preserves. It slows decay. It protects fragile molecules from breaking down. It holds a kind of chemical sleep, where bonds are safe and change is paused. It makes the fast processes of fire and fusion take a breath, slow down, wait for the right moment. In this way, ice is not static. It is strategic. It chooses the long path. And the universe, vast and patient, respects that path. Imagine now a single grain of cosmic dust floating alone for millions of years in interstellar space. Slowly it gathers a coat of ice. Slowly it joins others. Slowly a cloud forms. A star begins. A planet shapes. And maybe someday a breath is drawn. All from that first frozen layer. All from a crystal that held on long enough to begin something. Ice is not fragile. Ice is the architect of endurance. In the silence of cold, in the dark between stars, in the slowness of time stretched wide, ice builds, and what it builds becomes everything. Now, let us follow the story of ice to its quiet end, or perhaps to its eternal beginning. For though ice melts, sublimates, vanishes into vapour, the role it plays in shaping the universe is lasting. Even when it disappears, the imprint it leaves behind remains. Ice is not just a presence, it is a memory cast in stillness, a blueprint pressed into dust, a soft architect that designs by vanishing. In its silence, it teaches us the art of becoming. In the grand timeline of the cosmos, ice is more than a temporary state. It is a phase of preparation. It is the pause between ideas, the breath between birth and bloom. Wherever the universe builds something long-lasting, whether planets, stars, or atmospheres, ice plays a part. And though we often think of fire as the creator, it is cold that lays the groundwork. It is the invisible hand that gathers, that holds, that shelters until the moment is right for warmth to take over. Consider the journey of a comet, wandering for eons in the deep freeze of the Kuiper Belt or Oort cloud, carrying ancient ice wrapped around grains of dust. These frozen bodies orbit silently, far from any sun, preserved like seeds in a deep winter. And then, one day, something changes. A gravitational tug, a collision, a slow spiral inward, and the comet begins its long fall toward light. As it approaches the inner solar system, its ices vaporize, shedding tails of gas and dust, leaving a trail of light across the sky. In this transformation, the comet does not lose itself. It reveals itself. It becomes visible not despite its melting, but because of it. This cycle of ice gathering in silence, then melting into spectacle, plays out everywhere. In the rings of Saturn, ice continually collides, shatters, reforms. On the moons of the outer planets, geysers erupt from subsurface oceans, releasing icy plumes into space. On Pluto, nitrogen ice crawls across plains in slow glaciers. Even in the densest interstellar clouds, where the birth of stars is just beginning, icy particles swirl and shape the environment. These motions are not accidents, they are choreography, the slow, cold dance that brings galaxies into being. And here on Earth, we too live by the grace of ice. The polar caps regulate the planet's climate by reflecting sunlight. Glaciers feed rivers that nourish forests and fields. Frozen soils trap carbon, influencing the air we breathe. Even now, as climate changes, the melting of ancient ice releases gases held for millennia, reminding us how much is stored in every frozen form. Ice is not just a builder, it is a keeper of stories, of balance. We store our memories in ice. Cores drilled from Antarctica and Greenland reveal bubbles of past air, layers of ancient snow, dust from volcanoes, and deserts long gone. These layers speak without voices. They show us what the Earth was, what it has endured, how it breathes over centuries. To hold one of these cores in hand is to hold the past, frozen in place, waiting to be heard. But ice speaks in other ways too. It sings. On a frozen lake you may hear sharp, distant echoes, the cracking of expansion, the vibration of trapped gases. These sounds are not chaos. They are music, the Earth expressing itself through temperature and time. Astronomers believe similar sounds may exist on the icy surfaces of distant moons, the echoes of subsurface oceans knocking gently on their crusts. In this way, ice becomes a medium of sound, not just light, a bridge between silence and song. As technology improves, we are beginning to imagine travelling to these frozen places. Missions to Europa and Enceladus may soon drill into their icy crusts, searching for signs of life in the dark oceans below. Rovers on Mars dig through its frosty soil, hoping to find ancient water. Telescopes scan the outer edges of our solar system for icy objects too faint to see before. And each new mission carries a quiet hope that within these frozen realms we will discover more than elements. We will discover echoes of origin, hints of life's ingredients, proof that cold does not only preserve, but prepares. This preparation is not a passive act, it is an invitation. Ice holds things in place not to imprison them, but to protect them until they're ready. It pauses reactions, suspends molecules, shapes environments. In a universe of heat and violence, ice is the steady hand, the gentle memory, the hidden current beneath the brightness. And perhaps this is the most humbling truth of all, that the coldest places are often the most generous, that what seems lifeless may be rich with waiting, that silence is not emptiness, but a space for something to grow. In the dark, icy corners of space, the universe is always building, always dreaming, always setting the stage for warmth to take its turn. So now, the next time you feel frost on your window or see snow falling in slow spirals through the air, remember that these are not simple things. They are echoes. They are local expressions of a cosmic truth. The same physics that forms snowflakes on your palm also forms stars from frozen clouds. The same patterns that shape frost on glass shape rings around planets. The same chill that stills your breath also holds the beginnings of galaxies. Crystals in the sky do not shout. They do not burn, but they endure. They gather. They shape. They make the universe not only visible, but possible. And through them we remember that beauty does not always rush. Sometimes it drifts. Sometimes it sleeps. Sometimes it waits patiently in the cold, building everything we will one day come to see. Time, like light, is something we often think of as constant, a steady river flowing forward, never stopping. But in the coldest places in the universe, those vast frozen stretches between galaxies, within dark clouds of gas, inside the chambers of our deepest laboratories, something happens to time. It doesn't stop, not quite, but it slows, it stretches, it softens its grip. In the silence of extreme cold, where atoms barely move and energy grows faint, time begins to feel different. It begins to feel still. And in that stillness, we find something strange. Not the absence of time, but its transformation. A quiet version of time, a frozen time. To understand this, we must first understand what time is, not just the ticking of clocks or the turning of calendars, but the deeper measure, the change of things. Time is motion. It is decay. It is the shift from one state to another. It is a candle burning, a leaf falling, a thought forming. Every moment we know is marked by some kind of change, and that change requires energy, heat, movement, vibration. But what happens when we take that energy away? As we cool a system, the motion slows. Atoms that once bounced and collided now drift. Vibrations shrink. Reactions take longer. Chemical bonds form and hold. Decay slows. In this slowing, time seems to thin, not in the way that breaks clocks or calendars, but in the way that bends perception. At near absolute zero, a cloud of gas may stay unchanged for hours, days, even years. Not because nothing is happening, but because everything is happening so gently that the usual markers of time begin to blur. This is not imagination, it is measurable. In cryogenic environments, where molecules are suspended in near-perfect stillness, scientists have observed processes that at room temperature would complete in seconds, taking hours or more. Certain quantum states, so delicate under normal conditions, become stable. Memory in atomic systems can last longer. Noise fades, and in the hush that follows, a kind of clarity arises. The ticking is still there, but so soft it feels like silence. And yet time does not truly vanish. Even in the coldest vacuum, quantum rules insist on a kind of minimal dance. Particles still tremble, just barely. This tremble, called zero-point energy, is what keeps time from freezing entirely. It is a kind of cosmic heartbeat, too faint to hear, too steady to stop, and it tells us that even in the deep cold time flows, but it flows like a glacier, not a river. Like breath in sleep, not running footsteps. In outer space, especially in regions where starlight is weak or absent, temperatures plummet. At just a few degrees above absolute zero, interstellar molecules move so slowly that reactions are rare. This allows complex compounds to form and linger, long carbon chains, alcohols, even amino acids. These molecules, once created, can drift unchanged for millennia, waiting for a warmer place to awaken them. Ice in these regions traps gases and locks them into place. Comets carry them across the solar system. Planets gather them up, and the chemistry of life held in suspension begins again when the time is right. Back on Earth, cryopreservation uses these same principles to store cells, tissues, even entire organisms in a slowed state. At very low temperatures, biological processes pause, decomposition halts, enzymes stop working. The machinery of life waits. Frozen embryos, seeds, and stem cells are kept this way for years. Not dead, not alive in the active sense, just paused. Their time borrowed, folded, held. And in materials science, we see the same pattern. Cold, slow structural changes. Alloys freeze into shape. Crystals form with fewer defects. Superconductors carry current without resistance, not because energy has increased, but because motion has decreased. Order arises not through speed, but through slowness, through stillness, through time that has relaxed its grip. In this way, temperature and time are intimately linked. The hotter something is, the more time seems to rush. Reactions burst, systems collapse, decay accelerates. But as things cool, time widens, it gives room, it creates stability, and from that stability, beauty grows. Think of snow falling on a windless night. Each flake descends in a pattern shaped by frozen time, its symmetry built molecule by molecule, as water freezes around dust, spiraling outward in fractals too fine to see. No one rushes the snowflake. It is crafted by cold, by quiet, by stillness. It is time slowed into shape. Now imagine a nebula, a vast cloud of gas and dust, spread across light years, slowly collapsing under its own gravity. The cold inside it ensures that particles don't scatter, that fragile molecules remain intact, that complex chemistry unfolds without disruption. It may take millions of years for a star to form, but none of that time is wasted. It is all part of the preparation. The cold gives the cloud time to breathe, to gather, to become. And isn't that what frozen time really is? A chance to become, a chance to hold, to preserve, to wait for the right moment. In a universe where heat often dominates, where explosions, collisions, and entropy rush everything toward disorder, cold reminds us that slowness has a role, that pause has a purpose, that waiting is not wasting. Sometimes it is the most powerful thing of all. Frozen time is not a contradiction. It is a gift. It gives the universe space to organize, to heal, to reflect. And though we may never live in the deep silence of absolute zero, we can feel its echoes in the sleep that restores our minds, in the quiet that clears our thoughts, in the stillness that lets us see what motion always hides. This is what the cold teaches. Not only that time can slow, but that in slowing it can reveal its shape. It can become gentle. It can cradle instead of carry. It can offer not just direction, but depth. And within that depth something begins. Something lasting, something true. Let us move gently deeper into the nature of time, not as we normally know it, with seconds and minutes and the ticking pulse of clocks, but as it behaves in places where the universe nearly stops moving. In the silence of deep cold, time begins to reveal layers we rarely see. Not the arrow that races forward, but the ocean underneath. A calm so wide, so slow that the events within it seem to drift rather than unfold. Frozen time is not simply slower, it is softer. It bends the rhythm of being. It lets the smallest details expand. It gives room for structure, memory, and change to happen without noise. In warm systems, every particle is a rush of energy. Atoms vibrate, electrons jump, molecules twist and collide. In this dance, events happen rapidly. Chemical bonds break, new ones form, materials shift. Life pulses and decays. But as things cool, motion slows. Atoms begin to hold still. Patterns emerge and persist. Processes that once blurred into each other begin to separate. In that separation, time becomes visible. Like pausing a movie frame by frame, the frozen moment lets you study what warmth always rushes past. Consider a simple gas, hydrogen perhaps, trapped in a sealed chamber. At high temperatures, its molecules move so fast they slam into the walls thousands of times per second. But as it cools, those impacts slow. The molecules travel in longer arcs, wait longer between collisions. Eventually, when the temperature is low enough, their behavior shifts completely. They no longer act as isolated particles, but begin to exhibit quantum behavior, blurring into waves, overlapping, interfering. Time in that chamber no longer follows classical intuition. It stretches and loops, shaped by probabilities rather than paths. In ultra-cold quantum systems, like those used to form Bose-Einstein condensates or explore superconductivity, time becomes almost abstract. A single quantum state may last indefinitely if untouched. Its coherence, its ability to remain unchanged, relies on the absence of heat. The colder the system, the longer the coherence. At temperatures near absolute zero, coherence times can extend dramatically. These experiments show that time, like matter, is something that can be protected, preserved, lengthened, not by speed but by stillness. And this preservation is not limited to the lab. In nature, we find it everywhere. Cold slows life to a whisper. Arctic and alpine plants sleep beneath snow for months, resuming growth only when warmth returns. Hibernating animals enter deep metabolic suspension, where their bodies consume almost no energy, their heartbeats drop, their breath slows to near stillness. This is not death. It is life choosing to wait, life trusting time to hold it gently. The same principle appears in seeds that lie dormant for decades in dry, frozen soil. Only when the right conditions return do they awaken, stretch, and begin again. Their time is not wasted, it is stored. In the slow pulse of glaciers, in the drip of water through frozen caves, in the silent rotations of icy moons, we see this same patience, this same deep rhythm that cold allows. These are not places of absence, they are places of preparation. In physics, we define entropy as the measure of disorder in a system. As entropy increases, time seems to move forward. The broken becomes more broken, the mix becomes more mixed. But in very cold systems, entropy slows, disorder pauses. For a brief moment, things may become more ordered. The arrow of time bends. It does not reverse, but it softens its urgency. Cold creates a kind of temporal sanctuary, where things can linger on the edge of change without falling into it. This effect is why deep cold is so vital to preserving fragile systems. A biological sample stored in ice can resist the decay of proteins, the breakdown of membranes, the degradation of DNA. A delicate quantum state protected in a cryogenic chamber can survive long enough to be studied, used, and understood. Without cold, time devours. With cold, it delays. Not to avoid endings, but to extend beginnings. Imagine now the role this frozen time might play on other worlds. On Europa or Enceladus, icy moons orbiting gas giants, we believe subsurface oceans lie beneath thick shells of ice. These shells may be tens of kilometers deep, insulating the water below from the vacuum of space, but they also insulate time. Whatever chemistry is occurring in those hidden oceans, it is unfolding slowly, protected by the cold. If life exists there, it has had time not in rushes, but in long stretches. Its evolution shaped not by heat, but by pause, not by urgency but by endurance. Even the early universe felt the effects of frozen time. Moments after the Big Bang, the cosmos was unimaginably hot and dense, but as it expanded, it cooled. And in that cooling, things slowed just enough for matter to form. Protons found electrons. Atoms settled into place. Light decoupled from matter and began to travel. Without that cooling, without that first great slowing, structure might never have emerged. Galaxies may have never formed. Cold allowed the universe to shape itself. And what of us? What of human time? We often think in heat, in speed, in deadlines and burning energy. But in the quiet of winter, in the hush of snowfall, in the stillness of long nights, we feel a different kind of time, a time that lingers, a time that listens, a time that doesn't demand progress but offers reflection. It is in these moments that we begin to see frozen time in ourselves. Not a lack of movement, but a deeper awareness of it, a widening of perception. Frozen time does not erase action, it reframes it. It says, wait, listen, let the moment unfold slowly enough to see what it really holds. This is not inertia, this is grace. It is the cold asking us not to run but to rest, not to burn but to remember. In this way, frozen time is not the opposite of life. It is its hidden rhythm. And within that rhythm, the universe continues, not always loudly, not always quickly, but always, always becoming. Now let us bring this journey into frozen time to its soft conclusion, not with urgency, but with the same quiet slowness we have followed all along. For the more we dwell in the deep cold of the cosmos, the more we understand that time is not a machine grinding forward, but a shape that changes with motion, with heat, with stillness. In the warm chaos of everyday life, time feels narrow, like a road moving too fast. But in the cold, time spreads, it opens its arms. It becomes something wider, something gentler, something more alive than we expect. In the coldest corners of the universe, where particles barely move and radiation fades into silence, time continues, but it continues like a whisper. There is no ticking clock, no shuffling of minutes. There is only the slow evolution of possibility. A grain of interstellar dust, wrapped in a frozen shell of water and methane, may drift for 1,000,000 years before meeting another. That moment, 1 in a trillion, may start the birth of a star, or a world, or a chain of molecules that someday becomes breath, but all of it waits. Cold gives that grain the patience to be ready. This patience is what defines frozen time, not because nothing happens, but because things are allowed to happen without pressure. At extremely low temperatures, atoms arrange themselves into perfect lattices. These crystalline structures don't just hold form, they hold time. Their patterns remain unchanged for centuries, even millennia. They are clocks that don't tick, calendars without dates, and yet they remember, they preserve. Scientists study these crystals and their quantum vibrations to understand time at its smallest scales. They look at how a system returns to its original state, how coherence is lost, how entanglement decays, and what they find again and again is that cold slows the breakdown. Cold keeps the structure. Cold lets the story last longer. It is not that time halts, but that cold holds it like a steady hand guiding a flame in the wind. And if we shift our gaze from atoms to galaxies, we see the same truth. There are places in the universe where time moves with glacial grace. Galaxies drifting in near-empty space unperturbed by collisions or nearby stars, evolve slowly over billions of years. Their stars orbit in quiet symmetry, their gas clouds remain intact. They are not frozen in the sense of being inert, they are simply undisturbed. The cold of space gives them that gift. Even in black holes, where time is bent by gravity into extremes, the edge, the event horizon, marks a place where time appears to stop from an outside perspective. The deeper into gravity's well you go, the slower time passes for you. A traveller falling toward the horizon would feel nothing strange, but to someone watching from afar, that traveller would seem to freeze, caught not by force but by time's distortion, a final form of frozen time. Back on Earth, we find echoes of this in the art of preservation. A photograph captures a moment, still and silent. A fossil preserves a gesture in stone. A snow-covered field erases footsteps, returning everything to a blank beginning. These are not just metaphors, they are reminders that time can be held, that memory can be cooled, that life doesn't have to be constant motion to be meaningful. In the language of physics, frozen time allows us to study systems in their most ordered state. In biology, it lets us store what is fragile. In astronomy, it reveals the patient workings of the universe. And in the quiet of our own thoughts, frozen time gives us room to feel, to reflect, to exist without rushing. There is a kind of compassion in this slowness, a reminder that we are not machines, that our lives are not made only in fire and speed, that rest is not a pause in the story, it is part of it. In frozen time, the universe whispers, it's okay to stop, to wait, to breathe. And that whisper, soft as it is, carries more weight than all the shouting of clocks. The seasons know this. Winter is not the death of the year. It is its quiet memory. Trees don't die, they dream. Fields don't vanish, they rest. Beneath the frost, seeds hold their shape, waiting for the warmth that will call them forward. Time in winter is not wasted, it is gathered. So too with us. When we feel slowed, still, distant from the rush of life, we are not broken, we are in a season. A cold one maybe, a silent one, but not an empty one. There is growth happening in the stillness, there is healing in the quiet, there is shape in the frozen breath. And in the cosmos, the very same truths apply. Galaxies drift but do not disappear. Stars fade but do not forget. Molecules rest in dust, waiting to become clouds, waiting to become light. Frozen time is not the absence of life, it is its careful unfolding. So now, as this story nears its end, imagine a place in space where nothing stirs, where the cold is so deep it hums, where atoms have stopped arguing, where molecules do not rush. In that place, time breathes once every 1,000 years, not because it is tired, but because it is whole. It moves with intention, it holds instead of hurrying, and there, in that perfect stillness, something beautiful begins, not with a flash, not with a shout, but with a slow, steady becoming. That is frozen time, not an ending, but a place where beginnings are carefully held until they are ready to bloom. Out in the silent stretches of space where warmth has long faded and light arrives only in whispers, there floats a kind of dust that does not shine on its own. It does not glow or burn or pulse with energy. And yet this dust is what gives the universe its colour. It is made of tiny particles, carbon, silicates, ice, so small they can drift for millions of years without touching anything. And when starlight stretched thin by distance finally reaches them, something soft and unexpected happens. The light bends, it scatters, it glows in ways it never would on its own. And in that moment, frozen dust becomes a painter. The cold creates colour. To understand this, imagine starlight travelling across the universe. In the vacuum of space, it moves untouched for ages, perfect, unbroken, pure. But when it encounters dust, even just a grain, the light reacts. The smallest wavelengths, blues, violets, are scattered more than the longer reds. The dust filters the light, splits it, softens it. This is why nebulae, those great clouds of gas and dust, glow with their pale blues and pinks and purples. They are not lit from within, but from without. Their colour is borrowed. Their beauty is revealed by cold particles redirecting warm light. This scattering is called interstellar extinction, and while it dims the brightness of stars, it also reveals the shape of what would otherwise remain invisible. Without dust, we would see stars. But not the space between them. The cold, slow-moving dust gives form to the void. It sculpts outlines, creates silhouettes, gives the galaxy texture. And in doing so, it also reveals colour. Not colour in the sense of pigment, but in the subtle balance of wavelengths, the soft hues of space drawn in shades of scattered light. But dust alone is not enough. It must be cold to survive. In warm environments, molecules break apart. Dust is blown away by solar winds, melted by radiation, consumed in the furnace of stars. Only in the cold, where energy moves carefully, where particles drift instead of collide, can dust persist. And so the cold protects the colours of space. It gives them time to emerge. These dust grains often form in the outer shells of dying stars. As a star begins to shed its outer layers, it cools. Atoms join into molecules, which stick together and begin to condense into solids. Carbon atoms create soot-like particles. Silicates and metals freeze into crystals. Ice wraps around them, and from this quiet debris, ejected into space like breath, dust is born. It drifts outward, joining the interstellar medium, waiting for the right light to find it. And when that light arrives, soft, ancient, patient, it paints. The Horsehead Nebula, the Pillars of Creation, the Veil Nebula, these celestial portraits exist not only because of light, but because of the dust that holds it, bends it, scatters it just enough to let our eyes see something more than emptiness. Without the cold that forms and preserves dust, these structures would remain invisible. The universe would be lit, but flat, bright, but blank. It is the subtle interplay of light and cold dust that creates depth, contrast, colour. On Earth we see this too. The blue of the daytime sky is caused by the scattering of sunlight by molecules in the air, shorter wavelengths sent in every direction. At sunset the light travels through more atmosphere, and the shorter wavelengths are scattered out, leaving reds and oranges. The principle is the same in space, only colder, slower, quieter. The dust does not shine, but it shapes what shines. And some of that dust has made its way here. Micrometeorites, tiny pieces of cosmic dust, fall on Earth every day. They collect on rooftops, in glaciers, on the seafloor. Examined under microscopes, they show iridescent colours, metallic patterns, signs of ancient formation. Many are unchanged for billions of years, older than Earth itself. They carry the memory of dying stars, the fingerprints of forgotten galaxies. And within them, locked in tiny veins of frozen minerals, is the colour of the cosmos. Not bright, not loud, but enduring. The James Webb Space Telescope has recently begun to reveal these colours in unprecedented detail. Its infrared eyes see through dense clouds of dust, capturing the warm glow of stars forming inside cold cocoons. The images it sends back are filled with unexpected hues, amber, indigo, rose, drawn not by artists but by physics. These colours are not added, they are revealed. And the reason they can be seen at all is because cold dust holds them just long enough to become visible. In laboratories, scientists are recreating these conditions, chilling chambers to mimic space, studying how light interacts with the ice-coated particles. They find that the shapes of the grains, the layers of frozen gases, the structure of the crystal, all affect the light that passes through. The colder the environment, the more delicate the interaction. At low enough temperatures, even subtle differences in angle and material create shimmering shifts in wavelength. It is, in a way, light learning to listen to matter, and matter shaped by cold finally speaking. These discoveries are not only about colour, they are about the hidden influence of quiet things. Dust, once dismissed as mere debris, is now understood to be essential. Cold, once thought to be a dead state, is now known to preserve complexity. The interplay of the two creates something unexpected, beauty born from stillness. So next time you look up at the stars and see a patch of colour, a pale glow, a soft streak, a faint blur, remember that what you are seeing is not light alone. It is light transformed by dust, shaped by cold, offered to your eyes by a universe that has learned how to pause. The cold that created colour did not shout, it waited. It held light gently, like a mirror softened by age, until the picture appeared. And in that picture, we find not just beauty, but evidence that silence can shape brilliance, that cold can reveal warmth, that the darkest parts of space can hold the most delicate shades. This is the cold we rarely feel, but always see, the one that colours the cosmos. Let us step more deeply into the world shaped by frozen light and drifting dust, where colour is not made through fire, but through patience. In this quiet theatre of space, where temperature falls close to absolute zero and time stretches long between events, it is not the stars alone that shape what we see. It is the cold, invisible particles that hover in between. They do not shine themselves. They do not call attention to their presence. But they are always there, and through them the universe reveals its softer tones. These grains, shaped in stellar deaths and scattered by cosmic winds, are the brushes that colour the galaxies. Cosmic dust begins its life in the furnace of a dying star. As stars near the end of their lives, they expand and cool. Their outer layers swell and shed into space, rich with heavy elements forged over billions of years. In this expanding envelope, temperatures drop just enough for atoms to begin clinging together. Molecules form, then condense into solids, tiny crystals of silicates, graphite, and even diamonds. Water molecules find their way into the mix, freezing into fragile coats. These grains, only a fraction of a micron wide, float outward, carried by light pressure and stellar winds. Once released, they may never return, but they remain. As these grains travel through space, they collect stories. They pass through ionized gas, gather icy mantles in dark clouds, and carry with them the signatures of the elements that built them: hydrogen, oxygen, carbon, iron. Each contributes to how the dust bends, scatters, and absorbs light. When we look at the sky with telescopes, we are not just seeing stars, we are seeing the fingerprints of dust on light that has travelled across unimaginable distances. We are seeing colour not as a surface, but as an effect. A whisper left by a particle that shaped the light just enough to turn it into poetry. In the coldest regions of space, dust gathers with gas to form molecular clouds, vast regions where temperatures fall to just a few degrees above absolute zero. Inside these clouds, starlight cannot reach. The dust grains shield everything within, keeping it dark and cold. But this darkness is not empty. It is a cradle. Within it, new stars are forming, and around those stars, new disks of dust and ice begin to circle. These disks will become planets, comets, moons. They will inherit the dust that once drifted through space for billions of years, and they too will glow, faintly, softly, when the light finds them. Some of this light, especially in the infrared, is heat left over from when the dust was last touched by a star. Even in the coldest conditions, dust can retain a trace of warmth, and that trace becomes a glow, a gentle red or orange halo captured by telescopes. This glow is not hot enough to feel, but it is warm enough to see. It paints the outlines of galaxies, reveals hidden structures in star-forming regions, and tells astronomers where matter is gathering, waiting to become something more. But the most delicate colours arise from reflection. When starlight hits the surface of a dust cloud, it can bounce off in many directions, just as sunlight reflects off fog or smoke. This scattered light becomes visible from Earth as soft blues and greys, colours that echo the cool tone of twilight skies. The famous Pleiades star cluster, for example, shines with a faint blue mist, not from the stars themselves, but from the light they reflect off nearby dust. The stars are burning hot, but the colour we see is a result of the cold. This paradox lies at the heart of cosmic colour. Warmth creates the light, but cold gives it form. Without dust to scatter and soften it, the universe would be harsh and sharp, stars would be points, planets would be shadows, and galaxies would lose their structure. But with dust, especially cold dust, the light becomes art. It bends, it paints, it breathes through the void, turned by invisible hands into something we can not only study but admire. On the smallest scale, this process happens within icy mantles. When atoms and molecules freeze onto dust grains, they don't just sit still, they form layered structures, tiny films of water, carbon dioxide, ammonia, and methane. When ultraviolet light from distant stars strikes these ices, it can spark reactions, creating complex organic molecules. This chemistry, hidden inside the cold, may be the first step toward life. And even as the dust carries these ingredients forward through space, the light passing through it becomes tinged with their signature, the colour of possibility. In our own solar system, comets provide living examples. When they approach the sun, their ices sublimate, turning directly from solid to gas, and release trapped dust into a glowing coma and tail. The sunlight scattered through this material produces the classic greenish hue of many comets, tinted by the breakdown of organic compounds. We do not see the ice itself, we see the colour it leaves behind. Even more subtly, some grains contain tiny iron particles or complex hydrocarbons that absorb certain wavelengths more than others. This selective absorption changes the colour of starlight passing through dusty regions, making distant stars appear redder, a phenomenon known as interstellar reddening. It is not the same as a sunset, but it is similar in feeling. The presence of dust adds depth, emotion, story to the light. It becomes more than just brightness. It becomes experience. And through it all, the cold remains essential. Without cold, the dust would not form, the ices would not freeze, the reactions would not occur, the particles would be blown apart by heat and light. But the cold allows them to persist, to gather, to change gently. It lets the dust hold onto light just long enough to shape it. It allows colour to happen slowly. It is easy to forget that what we see in space, those brilliant images, those glowing clouds, those bands of subtle hue, is not colour in the traditional sense. It is filtered, scattered, stretched light, transformed by distance, temperature, and dust. What reaches us is not the original glow, but the story written upon it, a story that could not exist without cold. And so, in every shade of space, every blue veil, every amber mist, every ghostly glow, there is the touch of frozen matter, a touch so faint it cannot be held, so small it cannot be seen, and yet without it the universe would be colourless. The cold does not fight the light. It gives it something to rest against, a silence in which it can sing. Now let us bring the story of frozen light to its final delicate moment, not with a flash, but with a breath. For everything that colour becomes in the universe, every shimmer of a nebula, every blush of a distant galaxy, every reflection on a comet's icy trail, begins with something cold, something quiet, something almost invisible. These grains of dust, forged in the fading breath of ancient stars and carried gently through the void, do not announce themselves. They wait, they listen, and in their stillness, they hold light long enough for us to see what it means. It is the interplay between cold and light that teaches us about patience in beauty. When starlight rushes through the vacuum, it remains untouched, pure but unshaped. It is only when that light meets cold dust, dust that does not move quickly, that does not absorb greedily, but instead bends the light softly, that colours are born. In this subtle act, frozen dust performs a kind of alchemy. It transforms brightness into presence. It makes space feel near. It gives light a place to rest. And that rest is where story happens. In the Orion Nebula, the colour we see from Earth is not the result of just hot gas, but of cold dust filtering starlight across layers of cloud and ice. The rich reds and purples, the soft greys and golds, they are signatures not only of temperature, but of silence. Each hue is a kind of time capsule, a record of how far the light has travelled, how long the dust has waited, how gently the cold has guided the path of energy through space, and in this guiding the dust does not remain unchanged. Cosmic rays, starlight, even time itself alter its chemistry. The icy coatings on the dust grains are etched by ultraviolet light, forming complex molecules, some of which resemble precursors to life. These are not loud reactions, they do not explode or radiate, they whisper, they unfold slowly hidden in the dark. And then, when warmed, by a star's birth or a comet's passing, the dust releases its memory. It lets go. And what we see in that release is not just gas or light, but colour that tells a story billions of years long. Some of these grains survive entire solar systems. They are trapped in asteroids, in icy moons, in meteorites that fall to Earth. Inside these tiny travellers, scientists have found complex organic molecules, evidence that coal dust is not just passive matter, but a carrier of potential, a cradle for chemistry, a traveller between stars. This is why frozen dust matters, not because it is bright, but because it lets brightness become something more, not because it is alive, but because it carries the ingredients that life needs. In its structure, in its silence, in its refusal to rush, it holds on to what is important, and in doing so it gives light the time to soften, to bend, to bloom into colour. And perhaps this is the quiet truth the universe has been showing us all along, that beauty is not made only by heat, but also by restraint, that light is not most powerful when it blazes, but when it lingers, and that cold, far from being an absence, is a shaping hand, a painter's breath between strokes. Even on Earth, we reflect this truth. The most vivid sunrises come after the coldest nights. The clearest skies appear after winter storms. Ice crystals in high clouds refract sunlight into halos, sundogs, arcs of pale fire that float above the horizon like quiet rainbows. Snow itself, made of countless frozen hexagons, reflects light in a million directions, each flake a small prism of brilliance. The cold doesn't dim the world, it polishes it. And when we send our telescopes farther, colder, deeper, we find that the same principle holds. The farthest galaxies are seen not in the visible spectrum, but in the infrared, light stretched by distance, filtered by dust, preserved by cold. Without chill detectors, without careful shielding, without instruments wrapped in silence, we would not see them. Our tools must become as still as the dust they observe. They must listen more than they speak. They must wait, just as the cosmos has waited. There's something deeply moving about this, that in order to see the true colour of the universe, we must become more like it. Quiet, deliberate, patient. That the cold has something to teach us not just about atoms and light, but about how to look, how to slow down, how to receive instead of rush. And perhaps this is why colour means so much to us, not just because it pleases the eye, but because it reminds us that time and silence can combine to create wonder. That something as small as a grain of dust can alter something as vast as a beam of starlight. That cold is not the end of light, but its beginning. So when you next see an image of a galaxy, a nebula, a faint cloud glowing in space, know this: you are seeing more than light. You are seeing cold dust turning that light into art. You are seeing the universe reflect itself back to you, not with noise but with nuance, not with heat but with harmony. The cold that created colour did so slowly, softly, without need for praise. It drifted, it waited, it held. And in that quiet labour, the cosmos became not just visible, but beautiful. This is how the universe paints, not with a brush but with stillness, not with fire, but with frost, not in a hurry but in time.